All right, so you took a minute and you worked through and you decided, okay, no, these quantities are not proportional to one another. But there is something happening, right? Maybe some of you were tempted to say yes because of that $25 a month. And so let's take a look at the relationship that does exist. So in this problem with this table, one thing we could do is we could say, okay, instead of looking at just the number of months and the total cost paid, we can kind of like take a step out in our table. And so here we can say, okay, instead of talking about the number of months, let's talk about how the number of months since you joined changed. And so that little triangle there is just a shorthand for change. So if I was at the gym from 1 month to 2 months, that's a change of 1 month, right? I could do 2 minus 1, I get 1, right? Or if I went from 2 to 4, 4 minus 2 is just a change of 2 months. I've been there that much longer. From 4 to 10, right? That's 6 more months that I've been there. So I could I could also do that with the total cost paid. So I could come over here again. This is how my total cost since I've been at the gym has changed now. And so I could say, okay, well, from 125 to 150 is a change of $25. From 200 to 150 is a change. Sorry, 150 to 200 is a change of $50. And from 200 to 350 is an increase of $150. So now, instead of looking at the number of months and the total cost, what if we look at those changes, how the number of months changed and how the total cost changed? And so we could ask the question, are these quantities proportional to one another? So let's take a look, right? So if they're proportional, we should be able to show that using either scaling, constant multiple, or constant ratio. So let's start off. So constant scale factor. So if I double the change in time, will it double my change in cost? Yeah, it did there. So I have to still show it for 6. So if I went from 2 to 6, we can see that if I've been at the gym from 2 months to 6 months, that's 3 times as long. So if I take 50 and multiply by 6, will I get 150? Or sorry, by 3. Oh, sorry. And I say yes. So they have the constant scale factor between them. And so yeah, I've proven that these quantities are proportional because there's that constant scale factor. But just to beat a dead horse, let's keep going. I could show that by the constant ratio. And so I could just set up the ratio. So the change in cost over the change in number of months, is that always going to be the same? Right? So in this case, we'd say 25 over 1, 50 over 2, 150 over 6. And in each of these cases, if I simplify, I'm going to get 25. And so the answer again is yes. These quantities are proportional. Again, just to go one more time for constant multiple, right? So I could take the 1, and if I multiply 1 by 25, I'm going to get my change in cost. Okay, well, if I do that again, if I take 2 times 25, am I going to get my change in cost? If I take 6 times 25, am I going to get my change in cost? And again, in each case, we're going to say yes. And so it's not the quantities that are proportional, it's the changes in the quantities that are proportional. So that's a lot of words. So let's think about this. So the changes, right? So how those quantities are changing, right? The quantities are just the things that we're looking at, the things that we're measuring. And then we just define proportional to be these 3. So if the changes are proportional, we could say each of these statements. If you scale one change in quantity by some factor, you must scale the other change in quantity by the same factor, right? We could also say the ratio of the 2 changes in quantities are always constant, which is that unit rate idea. And lastly, we can say one change in quantity is always some number of times as large as the other. The one that we want to focus on right now is that second one. We don't generally use all those words and make it sound so wordy and confusing. Really, we can say this. So if the changes in quantities are proportional, we say the ratio of the changes is constant. And again, this is the way we kind of say it. So we say that there's a constant ratio, or rate is the word we use, of change. Right? Oh, right. So it's this big idea here, and maybe you're like, no, it's not. Right? But in math, this is a big idea. We define constant rate of change by saying 2 quantities are related by a constant rate of change if the changes in those quantities are proportional. And so we're going to take some time in the homework, and then as we keep going, we're going to build off of this idea, and really it's really going to lead us through a lot of this course. And so really this is kind of like setting the foundation for it all.